Hello, good afternoon, student. Today's date 10 October 2020, Saturday. My name is Hiral Raval. Standard ninth, subject Science. Chapter number 9, Force and Laws of Motions. Okay, student? In this chapter, we have already learned the first law of motions, balance and unbalanced force, then inertia and mass topic. Then we perform activity of a carom board. Okay, then we have performed another activity, 5 rupees coin. Then we have studied topic 9.3, inertia and mass. Then we have studied topic 9.4, the second law of motions and Newton's second law. Then we derive the mathematical formulations of second law of motions. Okay. Then we have studied the various examples. Examples 9.1, 9.2, 9.3, 9.4. Okay. Then we have studied the Newton's third law of motions. Okay students, Newton's third law of motions. ओके उसका एग्जाम्पल भी हमने देखा था, गन का एग्जाम्पल. ठीक है. देन वी परफॉर्म एक्टिविटी 9.4. ओके, टुडे वी हैव स्टार्ट द एक्टिविटी 9.4. रिक्वेस्ट टू चिल्ड्रन टू स्टैंड ऑन टू सेपरेट कार्ड्स as shown in figure 9.13. Okay, give them a bag full of a stand or some other heavy object. Ask them to play a game of catch with the bag. Does each of them receive an instantaneous reaction as a result of throwing the sand bag? You can paint a white line on cart wheels to observe the motion of the two carts when the children throw the bag towards each other. Okay, ये जो एक्टिविटी हम देखते हैं कि क्या किया है इसमें. यू कैन पेंट अ वाइट लाइन, हमें बीच में जो है वो वाइट लाइन बना देनी है. ओके, देन आस्क देम टू प्ले अ गेम ऑन कैच विद द बैग. वो जो बैग है उसको कैच करना है ना, ऐसी गेम उनको खेलनी है. यू कैन पेंट अ वाइट लाइन ऑन कार्ट व्हील्स टू ऑब्जर्व द मोशन of the two carts when the children throw the bag towards each other. Now, place two children on one cart and one on another cart. The second law of motion can be seen as this arrangement would show different accelerations for same force. Okay, दोनों जो कार्डबोर्ड है उसके नीचे व्हील्स लगाया है. ओके, सबसे पहले तो कार्डबोर्ड में जो खड़े रहना होता है ना, वो ही बहुत ही ज़रूरी है. हमारा बैलेंस नहीं रह पाता. हम कार्डबोर्ड में कैसे खड़े, हाउ टू स्टेडी ऑन द कार्डबोर्ड, हम कैसे उसके ऊपर खड़े रहे, वही एकदम इम्पोर्टेंस है ना, हमें एकदम केयरफुल रहना पड़ता है. नाउ प्लेस टू चिल्ड्रन ऑन द कार्ट एंड वन ऑन अनदर कार्ट. द सेकेंड लॉ ऑफ मोशंस कैन बी सीन as this arrangement would show different accelerations for the same force. ओके, दोनों सेम फोर्स से जो है एक दूसरे को जो है वो बैक पास अप कर रहे हैं. द कार्ट शोन इन दिस एक्टिविटी कैन बी कंस्ट्रक्टेड बाय यूजिंग 12 mm और 18 mm थिक प्लाईवुड बोर्ड of about 50 cm into 100 cm with two pairs of hard ball bearing wheels. स्केट व्हील्स आर गुड टू यूज़. हम स्केटिंग के जो व्हील्स यूज़ करते हैं वो बहुत ही अच्छे हैं. ओके, वो हम यूज़ कर सकते हैं. स्केट बोर्ड्स आर नॉट एज इफेक्टिव बिकॉज इट इज़ डिफ़िकल्ट टू मेंटेन स्ट्रेट लाइन मोशन. है ना, स्ट्रेट बोर्ड बहुत डिफ़िकल्ट रहता है. उसकी इफेक्टिव है. स्केट बोर्ड आर नॉट एज इफेक्टिव बिकॉज इट इज़ डिफ़िकल्ट टू मेंटेन स्ट्रेट लाइन मोशन. स्केटिंग के जो शूज़ है, स्केटिंग बोर्ड वो पहन के हम पहले तो है ना स्ट्रेट लाइन मोशन कर ही नहीं पाते, क्योंकि हम स्टेडी नहीं रह पाते. ओके, देन टॉपिक 9.6, कंजर्वेशंस ऑफ मोमेंटम. कंजर्वेशंस ऑफ एनर्जी का जो रूल्स है वो हमने देखा था, है ना, द लॉज ऑफ कंजर्वेशंस. दिस इज द न्यू टॉपिक, कंजर्वेशंस ऑफ मोमेंटम. सपोज two object, two balls A and B, say, of mass MA and MB are traveling in the same direction along a straight line at different velocities UA and UB. ओके, एक जो बॉल है जिसका मास एम ए है, देन वेलोसिटी यू ए, देन अनदर बॉल मास M2 MB and velocity UB respectively, figure 9.14a. And there are no other external unbalanced forces acting on them. Let UA greater than UB and the two balls collide with each other as shown in figure 9.14b. During collision, which lasts for a time t, the ball A exerts a force FAB on ball B and the ball B exerts a force FBA on ball A. Suppose VA and VB are the velocities of the two balls A and B after the collision. Okay, collision हो जाए. What is collision? The two balls are bounce each other, strike each other. It is called a collision. So after the collision, the velocity is VA and VB. Okay, respectively. Figure 9.14c. Okay, here show the diagram. Before collisions, mass MA and mass B MB, then the initial velocity UA and UB are there. Okay, shown in the figure. Then another figure B, A and B. After collisions, the force acting on each other, A to B, we write to FBA, and force B acting on A, we write FAB. Okay, then after collisions, situation C, MA and AB, VA and VB the velocity. Okay, after collisions. From equations 9.1, the momenta, plural of the momentum of ball A before and after the collisions are MA, UA and MA, VA respectively. The rate of changes of its momentum or FAB actions during the collisions will be MA bracket VA minus UA upon T. Similarly, the rate of change of momentum of ball B is equal to FBA or reactions during the collisions will be MB bracket VB minus UB upon T. According to the third law of motions, the force FAB exerted by ball A on ball B actions and the force FBA exerted by the ball B on ball A reaction must be equal and opposite to each other. Therefore, FAB is equal to minus FBA. Okay, the forces are opposite to each other. FAB is equal to minus FBA. So we write what is FAB. So MA bracket VA minus UA upon T is equal to minus MB VB minus UB upon T. This gives MAUA plus MBUB is equal to MAVA plus MBVB. Since MAUA plus MBUB is the total momentum of the two balls A and B before the collisions, and MAVA plus MBVB is their total momentum after the collisions from figure 9.7. We observe that the total momentum of the two balls remains unchanged or conserved provided no other external force acts. As a result of this ideal collision experiment, we say that the sum of momenta of the two objects before collisions is equal to the sum of momenta after the collision, provided there is no external unbalanced force acting on them. This is known as the law of conservation of momentum. I repeat, what is the laws of conservation of momentum? The sum of momenta of the two objects before collision is equal to the sum of momenta after the collisions, provided there is no external unbalanced force acting on them. This is the law of conservation of momentum. This statement can alternatively be given as the total momentum of the two objects is unchanged or conserved by the collisions. Okay, so this statement can alternative be given as the total momentum of the two objects is unchanged in conservations. Okay, then activity 9.5. Take a big rubber balloon and inflate it fully. Tie its neck using a thread. Also using adhesive tape. A thread. Fix a straw on the surface of this balloon. Pass the surface of this balloon. Okay, pass a thread through the straw and hold one end of the thread in your hand or fix it on the wall. Ask your friend to hold the other end of the thread or fix it on a wall at some distances. This arrangement is shown in figure 9.15. Now remove the thread tied on the neck of balloon. Let the air except from the mouth of the balloon. Observe the direction in which straw moves. धीरे धीरे straw जो है वो moves हो रही है. Okay. Activity 9.6. Take a test tube, a good quality glass material, and put a small amount of water in it. Place a stop cork at the mouth of it. Now suspend the test tube horizontally by two strings or wires as shown in figure 9.16. Heat the test tube with a burner until water vaporizes and the cork blows out. Observe that the test tube recoils in the direction opposite to the directions of cork. Okay, here the diagram. Also observe the difference in the velocity the cork appears to have and that of the recoiling test tube. Okay. Then example 9.6. A bullet of mass 20 gram is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the pistol? हमें पिस्टल की velocity find करनी है. Okay. Then we have the mass of bullet. The mass of bullet M1 is equal to 20 gram. We convert it into kg. 20 upon 1000. And the mass of the pistol M2 is equal to 2 kg. Initial velocity of the bullet U1 and pistol U2 is equal to 0 respectively. The final velocity of the bullet V1 is equal to 150 meter per second. The direction of bullet is taken from left to right, positive by convections. Let V be the recoil velocity of the pistol. Total momenta of the pistol and bullet before the fire when the gun is at rest 2 plus 0.02 kg. Okay. Total momenta of the pistol and bullet after it is fired 0.02 kg plus 150 meter per second plus 2 kg into V meter per second. So we have write 3 plus 2 kg per kg into meter per second according to the laws of conservations of momentum. Total momenta after the fire is equal to total momenta before the fire. So we have write 3 plus 2V is equal to 0. So V is equal to minus 1.5 meter per second. ये कैसे हुआ है ना, तो हम देखते हैं 3 plus 2v is equal to 0. Okay, so we have write -1 -1.5. Okay, negative sign indicates that the direction in which the pistol would recoil is opposite to that of bullet, that is it right to left. Okay, then the recoil of a pistol. This is the diagram. The girl jumps onto the cart. Okay, then 9.7. A girl of mass 40 kg jumps with a horizontal velocity of 5 meter per second onto a stationary cart with frictionless wheels. The mass of the cart is 3 kg. What is her velocity as the cart starts moving? Assume that there is no external unbalanced force working in the horizontal direction. Okay, then solutions. Let v be the velocity of the girl on the cart as the cart starts moving. The total moment of the girl and cart before the interactions, 4 kg into 5 meter per second plus 3 kg into 0. 3 into 0 तो 0 हो जाएगा और 40 into 5 we have write 200 kg into meter per second. Total momenta after the interactions 40 plus 3, so we have write 43. According to the law of conservation of momentum, the total momenta is conserved during the interactions, that is 43 v is equal to 100, so v is equal to 200 upon 43. so we आप करोगे डिवीजन तो पता चलेगा, आंसर मिलेगा 4.65 मीटर पर सेकेंड. The girl on cart would move with a velocity of 4.65 meter per second in the direction in which the girl jumped. Girl jump कर रही है. Okay, then another example 9.8. This is the last example of this chapter. Okay, but ये जो टॉपिक है वो ओमिट किया गया है. Okay, हमने जो नया सिलेबस भेजा ना आपको, मैंने जो PDF भेजी उसकी बात है. ठीक है, ये पूरा ओमिट किया है. दिस इज द कंजर्वेशन लॉज. All conservation laws such as conservation of momentum, energy, angular momentum, charge, etc. are considered to be fundamental laws in physics. These are based on observation and experiment. It is important to remember that a conservation law cannot be proved. It can be verified or disproved by experiment. An experiment whose result is in conformity with the laws verifies or substantiates the law. It does not prove that the law. On the other hand, a single experiment whose result goes against the law is enough to disprove it. The law of conservation of momentum has been deduced from large number of observations and experiment. This law was formulated nearly 3 centuries ago. It is interesting to note that not a single situation has been realized so far which contradicts this law. Several experiments of everyday life can be explained on the basis of the law of conservation of momentum. Okay student, तो आज के लिए जो क्वेश्चंस है, क्वेश्चंस क्या है? ओके, तो मेरा सबसे पहला जो क्वेश्चंस है वो है एक्सप्लेन द लॉज ऑफ कंजर्वेशन ऑफ मोमेंटम. वो आपको एक्सप्लेन करना है. ओके, एक्सप्लेन द लॉज ऑफ कंजर्वेशन ऑफ मोमेंटम. ओके, चलो एक ही क्वेश्चन देती हूँ आज मैं. ओके, 9th स्टैंडर्ड में, 9th स्टैंडर्ड वाले बच्चे बहुत कम जो बच्चे हैं वो आंसर्स देते हैं. है ना। तो आंसर आप दीजिए ना, आंसर क्यों नहीं देते हो आप? बहुत सारे 10th के बच्चे हैं, 7th 8 सारे बच्चे आंसर देते हैं, तो आप लोग भी आंसर दीजिए। ओके स्टूडेंट, है ना। थैंक यू।